Okay, so question number 9. This asks, what is the difference between polar and nonpolar covalent bonds? Okay, so when we have nonpolar covalent bonds, this is when two atoms have an equal or similar electronegativity values. So we can also show that the difference in electronegativity is around 0 to 0.5. Okay, so let's have an example. So some examples would include like diatomic molecules, so such as the nitrogen-nitrogen bond is considered nonpolar covalent since obviously it is the same atom. Its difference in electronegativity would just be equal to 0. Let's also look at the carbon-hydrogen bond and calculate its difference in electronegativity. I'm just going to Google electronegativity values. And you'll see that carbon has an electronegativity value of 2.5. And hydrogen has an electronegativity value of 2.1. So the difference between the two is only 0.4. So this lies in the range of 0 to 0.5. So that makes our carbon-hydrogen bond a nonpolar covalent bond. Okay, so now let's define what a polar covalent bond is. So when we have a polar covalent bond, this is when two atoms have dissimilar electronegativity values, and it leads to a dipole moment. Okay, so typically the difference in electronegativity for polar covalent bonds can range from 0.5 to around 1.69. Okay, so let me underline this as well. And let's look at some examples. So let's say we had the bond between oxygen and hydrogen. So let's calculate its difference in electronegativity. Oxygen has an electronegativity value shown here at 3.5. And hydrogen's is 2.1. So this difference in electronegativity is 1.4. So this lies within the range 0.5 to 1.69. So this makes the oxygen-hydrogen bond a polar covalent bond. So another example of a polar covalent bond would be between like phosphorus and fluorine. So another thing to note with polar and nonpolar covalent bonds is that these only take place, or these only occur between two nonmetals. So when we have these differences in electronegativities, these are going to be between the two nonmetals, because there is also something called an ionic bond. Let's do this in orange. Ionic bonds are between a metal and a nonmetal. And typically, they tend to have an electronegativity difference that is much higher, so greater than 1.7. An example would be like potassium fluoride. So the minute you see a metal that is involved in the bond, it's automatically not a covalent bond. It would be considered an ionic bond. So even if you, like let's say we calculated the difference in electronegativity of two nonmetals, and if it was greater than 1.69, the fact that it contains two nonmetals already means that it is not an ionic bond because it was between two nonmetals. So that's why you need to be careful when you calculate the difference in electronegativity of two atoms, because even if it doesn't lie within this range, it all depends on whether or not it takes place between two nonmetals or if it was between a metal and a nonmetal. Okay, so that's just like a little disclaimer. So that's why these ranges are kind of averaging out, because sometimes you might have two nonmetals, but their difference in electronegativity is like 1.71. So it wouldn't be considered ionic because it was two nonmetals. So the junior tutor said that covalent bonding happens when electrons are shared between atoms or molecules to attain stability or an octet. A covalent bond that has an equal sharing of electrons is called a nonpolar covalent bond. On the other hand, a polar covalent bond are formed when a pair of electrons is unequally shared between two atoms. Yep, so this solution is correct. Then I just also added that due to differences in electronegativity between two atoms, so let me just say that this typically greater than 0.5. This leads to an uneven share of electrons between atoms, so polar covalent bonds. Then I'll also add that the carbon-hydrogen bond is considered a nonpolar covalent bond because